Why do we need chemical nomenclature? Well, take nitrogen and oxygen. Nitrogen and oxygen can combine in many different ways, and this is just nitrogen and oxygen. It could be N2O, NO, NO2, N2O4, or N2O5. And all of these, and a lot of the different nonmetals can combine in a whole host of different ways. And we're talking about naming covalent bonds right now, covalent molecules, naming molecules, more or less. And remember, molecule is going to be a covalent bond, not an ionic bond. So we are naming these molecules, and it's just the idea is that different atoms can combine in a whole host of different ways, and this is just one example. And if we came up with a special name for all of these, well, we kind of have a lot of terms, a lot more terms than we want. And chemistry is already loaded with terms and names, so we have a little system, and we use prefixes. Mono is 1, di is 2, tri like triangle is 3, tetra, penta like pentagon, hexagon, heptagon, octagon, nonagon, decagon. So these are just prefixes that mean the number that you see over here, and we're going to use them. Okay, so we have some rules here, and we're going to figure out how to name these molecules. So we're going to name all 5 of these using these prefixes and these rules over here. First word is the name of the element appearing first in a chemical formula, including a prefix indicating how many atoms of that element are present, if more than one. Bold. So the first word is the name of the element appearing first. The first appearing element is nitrogen. And it says we have to put a prefix indicating how many atoms of that element are present. And the prefix we're going to use in this case is di, because there's 2 nitrogen. So we're going to call that dinitrogen. So that's the first part. Second part, the second word ends in "ide." So instead of oxygen, we're going to call it oxide. So we always end the second word with IDE, oxide. And it also has a prefix indicating the number of atoms present. Well, there's only 1 oxygen. So we're going to use the prefix 1. We're going to call it monoxide or monoxide, dinitrogen monoxide. And that's essentially how we do these. First word, you just write out the first word and put the prefix before it, whatever it has, as long as it's more than 1, and so on. For the second one, we know again we have nitrogen, but we're not going to use the mono, because for the first element, we only use these prefixes if there's more than 1. This is going to be nitrogen monoxide because there's 1 oxygen. We're not going to call it mononitrogen monoxide. We don't need to put the mono in for the first element. So again, we write the word nitrogen, and there's only 1 oxygen, which changed to oxide. We call it nitrogen monoxide. How about the second one? Again, we have 1 nitrogen, so we're just going to write nitrogen again. And how many oxygens do we have? We have 2. So we go up here and find 2. So NO2 is going to be nitrogen dioxide because there's 2. And N2O4, well, we saw up here N2 was dinitrogen, so nitrogen with 2, dinitrogen, and now we have 4 oxygens. So what's the prefix for 4? Tetra. So we're going to call that tetraoxide. Dinitrogen tetraoxide. And same thing down here, we're going to have dinitrogen, but not tetra. We're going to have penta, dinitrogen pentaoxide. So again, you don't memorize these prefixes, you just got to know how to use them to name chemical compounds, or molecules, I should say. Some things have special names, NH3. We could call that nitrogen trihydride, or we can call it ammonia. So again, there are special names in chemistry. Both names would work, but so let's just do 1 or 2 more. We'll do one without the oxygen. Let's do CF5. So the C is carbon. And it's 1 carbon, so we're not going to write in the mono. And we have fluorine. And how many fluorines do we have? We have 5. So that would be carbon penta and fluoride if it fits. Remember, it changes to IDE, ide, fluoride. And that's how we do these. Can we work backwards? We have nitrogen monoxide. So we don't have a prefix here, so we have 1 nitrogen. And how many oxygens do we have if it's mono? Monooxide means 1. There's 1 oxygen. So No, NO. So that's how we do that. What about di? Let's do, we'll just do carbon tetrafluoride. This again, there's only one carbon, so it's a C. Tetra means 4, so we have 4 fluorines. So we can work backwards. We can reverse engineer this. Dinitrogen is N2. Pentaoxide is O5. Silicon, there's 1. Tetrachloride is 4. And if we had a hexa down here, this would be 6. There'd be Cl6. Right? Silicon, there's 2 silicons. So that's how we do that. You can go backwards or forwards. If you wanted to practice, these are the answers. You can pause the video, go back to the questions, check it out. So let's just do 2 more examples, and we'll call it a wrap. Which of the following compounds is named incorrectly? We have 2 cases. So A, B, C, or D, which one's named incorrectly? We have carbon disulfide, carbon, C, that's fine. Disulfide, well, we have 2. Disulfide, that's correct. Boron, trichloride, well, there's boron, and we have 3, triangle, trichloride. Iodine heptafluoride, well, we have iodine, 1 I, that's fine. Heptafluoride, what's hepta? Hepta is 7, and we have 7. So obviously by elimination, the last one must be incorrect unless we made a mistake, but we have PCl5, phosphorus hexachloride. So let's look at hexa. Hexa is actually 6. So this one's named incorrectly. This would need to be a 6 to be hexachloride. And we'll do this bottom one too, see which one's incorrect. SbCl3, antimony trichloride, 3 is tri, that's correct. Dicarbon, di is 2, and we have 2 carbons. Pentaoxide, penta is 5, so pentaoxide works. Dicarbon pentaoxide, that's correct. Carbon tetrafluoride, we have 1 carbon, that's fine. How about fluoride? Well, tetra is 4, so carbon tetrafluoride is correct. Again, the last one is wrong. Hydrogen arsenide, well, the arsenide is fine, there's 1. What about the hydrogen? We have 3, so we didn't write trihydrogen arsenide, so we need to put a little tri in front of this. Or as this is written now, this would be just HAS. So hopefully that helps you with chemical nomenclature. This is Mr. Zapone.